There we go. Okay, if the thing you are measuring is exactly on a line, what would you need to add to the end? A 0. Or sometimes you may find that you actually need to add 2 zeros or even 3 zeros. Yeah, it depends on the smallest division between the lines. Yeah. Now this one is a little trickier because there's a lot of blanks and not many words. Anyone feel like they got this one? Yes?
Measure one more digit in the smallest marking on a measuring device?
Yes, always measure one more digit than the smallest marking on the measuring device. And in any measurement, the final digit is always yes, uncertain or estimated. Yes, sorry, I cut you off there. Estimated or uncertain. So I abandoned you at the end of class last day. So let's just go back and check on these because I had written down some bad measurements and you can maybe correct me on them today. So here we have our first one at the top of that page. Does that look like a good measurement or a bad measurement?
Bad.
It's pretty terrible. Okay, what's one thing that's terrible about it? I have 2 estimated digits. I am already guessing the 6. So I cannot have an extra 0. So let's get rid of that 0 there. All right. What else do I need to fix? I need to fix my unit. And someone who hasn't spoken to me yet today. Yeah. I need an equal sign, absolutely. And what do I need on that other side of the equal sign? Everybody.
I need what you're measuring.
I need what I am measuring. And so I'm not going to write down what I am measuring. I'm going to write down the symbol. What's the symbol for length? L. And then where am I going to put pencil?
Subscript.
Subscript down at the bottom, pencil. Okay. All right. And then we have our next one. Oh, I got my units this time. Well, pat on the back for me. Good job, Ms. Spence. However, is that a good measurement or a poor measurement? Poor measurement. What have I done wrong this time? Denny, what have I done wrong this time? Yeah, I need to have a 0.0 because am I unsure about that 6? No, I know that is a 6, right? There's no doubt. It's not like maybe it's 7, maybe it's 5. No. That's ridiculous. Okay. Is it maybe at home? Do you want to borrow a book? Yeah. Okay, cool. Let us find one for you to borrow. You can borrow this one. There you go. And you just take out the pages when you're done. Okay. So we are on page 67. Okay. So we need a 6.0 because our smallest division is 1 centimeter and 1 point position after the ones is the 0.1s. Good. And once again, what are we missing? Everybody? Yeah, the equal sign and length of pencil. Okay, so I think we can just go to our last one and say, oh, I forgot my length of pencil again. And
It's not gone down to the smallest marking.
yeah, our smallest marking here, this one's a 6.5. And this one, for example, is a 6.6. So the distance between those is 0.1. So we know the 0.1 for sure. We know the 6 for sure. That means we need to actually be guessing at the 0.0. So our smallest division is 0.1, so we go to the 0.01, and that is our uncertain digit. Okay? So on to significant figures in measurements. This is on page 68. I feel like there is a lot of blah, blah, blah in this little section, and I want to cut it down, so we're not going to read through every single little thing together. You feel free to read through everything if you want to, but I'm going to kind of try to cut to the chase a little bit, okay? Significant digits or significant figures, all the different ways we can say this. We can say significant figures is long, so we often will just say sig figs. Sig figs, that means significant figures. Because that's too long for me to write every time someone makes an error on a test. We're going to write just SF. You will also see it written, and I'm not going to write this whole one out, as significant digits. Sometimes they call them sig digs, but I don't like that. I don't know. Just didn't grow up with it. Didn't grow up with it, don't like it. 2 definitions. Definition number 1. All the meaningful numbers. What's a meaningful number? It's relevant. It actually has like some purpose to it, right? I mean, I could measure this pencil and I could say that this is 6.8317942. Which of those digits actually have some sort of meaning and which are just garbage that I've thrown in there?
6.8 is a sig fig.
6.8 are the sig figs. It's all your known digits. Those are your significant figures, plus that one estimated digit. So if you have made your measurement correctly, using the method we used last day, one more digit than the smallest division, then you will be able to just count your sig figs, and you will say, this is garbage, I have 2 sig figs. 1, 2, the 6 and the 8. Okay? This measurement has 2 sig figs. 1, 2. We can't write 6.70. We can't write 6.700. It's ridiculous. Now, sometimes you will actually see it written this way. I'm not going to have you do it, but you can write your measurement as 6.7 plus or minus 0.1 centimeter, right? Because that means maybe it's 6.6 or maybe it's 6.8. So if you wish to do that, you can, but I'm not going to require that this year, okay? This is a more precise ruler because it has smaller divisions on it. You can get measurements. If 2 people were to read this ruler, you would get measurements that are closer to each other. So this one could have been 6.6, 6.7, 6.8. This one here is 6 point what? Tell your partner. 6.7. Do I need another digit?
Yes.
Yes. 0, because I'm not like, is it 6.6? Is it 6.8? I'm not wondering that. Okay? 6.70. So this digit is the uncertain digit. And these 2 are our certain digits. And remember, significant figures are all of the certain digits, 1, 2 of them, plus the one uncertain digit. So how many sig figs? Just count them. You literally go, I have 1, 2, 3. Okay, it's as easy as that. How many significant figures do you have? If you've made your measurement correctly, you count the digits, and that's how many significant figures you have. Okay, so we have 3 sig figs. Yes?
I'm still trying to figure it out. Isn't there some like wonky rules around the zeros?
There is, but we'll come to those later. Okay? Yeah, just hold on to that thought for a little bit. Okay? Now, there's a lot of blah, blah, blah in here. The reason I actually wanted to mention that this is a more precise ruler is that if you were to guess at some other measurements, if you couldn't see it so blown up and big, you might say that it was 6.69. That's supposed to be a 9. It doesn't look like a 9. Or 6.71. Which set of measurements are closer to each other? The 6.6, 6.7, 6.8, or the 6.70, 6.69, and 6.71? Which ones are closer to each other? These guys here are closer to each other. They are only off by 0.01, right? So this is plus or minus 0.01, whereas these are further apart. And so this one is plus or minus 0.1. Yes?
So you just bring it up, like we can do it clearly because of how blown up it is.
Yeah.
But say, in a situation where, the smallest division goes to the 0.1, but it's kind of difficult to see. So in that case, we'll and so we're not entirely sure what the 0.1 is, we still add this.
You'll still add one just because we need a rule to follow in Chemistry 11. Okay? Yeah. Okay, so, and if you think about our measurements that are closer to each other, what does that make them? That makes them more precise. And measurements that are further apart from each other, that makes them less precise. In general, the more significant figures you have, the more precise your measurements will be. Okay? And let me know if ever anything is like too small, I can make it bigger, that kind of thing. Okay, so just down to the bottom of the page, I'm going to say, in general, more sig figs is more precise. Unless you've got some weird, wacky, like sort of, I don't know, maybe a digital readout and it's just like not working properly. So every time you plug it in, maybe it gives you a good number of digits, but it just gives you a different result every time. That could be a case where you have lots of digits, but it's not precise, but that would be because your equipment is faulty. Okay, we're going to try not to give you any faulty equipment here. Okay. Okay, so we already talked about this, so we're going to skip the next paragraph. Blah, 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 blah. Here we go. Example 3. The length of this object is clearly 0.8. Should it be recorded as 0.8, 0.80, or 0.800? What do you guys think? This one here. 0.8, 0.80, or 0.800. Tell your partner what you think. A student actually gave this to me.
Oh, I love this kind of book, but I can never find them.
I think you can get them on Amazon.
Oh.
This is Otraki. Otraki. O-T-R-A-C-K-I. Pardon me? What they do is when I do this, it means my screen doesn't move around. Right? So when I'm writing, I can use my hand and it won't like mess up with the computer won't think I'm trying to write with my hand.
Oh, that's crazy.
Right? So I'll either use this or I've got some fingerless gloves somewhere. I don't know where I put them, but yeah, the purple ones. Yeah. I kind of have a lot because I tend to put them in my pocket and take them home by accident. So I like to have a few lying around because then I always have one here. All right, what do we think? We're going to have our option A. Do we remember what A is? Did we learn this or was that my other block? Did we learn this?
What? No.
A's, B's, and C's? We need to learn A's, B's, and C's. Okay, so this is if you put your fingers on your palm and your thumb beside it, that's the letter A. Okay, that's the letter A. It kind of looks like an apple, right, with the little stem coming up. And then B, you open your palm and put your thumb on your palm. That's the letter B. Okay, so give it a try. We're going to do A, and then B. A, B. A, B. And then C is really easy. Okay, C is nice. D, sometimes people find D tricky. You take your pointer finger, your index finger, you point it up and you touch the rest of your fingers to your thumb. Okay, so pointer finger up and the rest of your fingers make a circle. And that's the letter D. Okay, so let's go to C. Pointer finger up is D. C, D. C, D. All right. Now, we don't need to do D because we only have 3 options here. We have A, B, and C, but often I will give you 4 choices, and I find it's a very effective way to just sort of get you involved without having too much technology out. So, do we like option A, 0.8? Do we like option B, 0.80? Or do we like option C, 0.8005432? Vote! All right. And it's also okay to be like, I don't know yet. That is a perfectly good option. Okay, I got lots of B's, so let's hope it's B. Let's see what Ms. Spence thinks. Does she, me also agree? Well, are we sure about that 8? Yes, we are. Yeah? So definitely 0.8. And then I say, well, it's right on that line. So it's going to be 0.80. And then I know for a fact that this is 0.1. So I should go to the 0.01, the 0.10, like the hundredths position. And so this is correct. Yes? Now, if you have the ability to zoom in super close like this, you might even be able to see that you could have read this as 0.79 centimeters, maybe. Like if you get up really close, maybe it's just a little bit less, but that's arguable, right? That is our estimated digit. We're having like a little argument over whether it's 0.80 or 0.79. Don't get freaked out by the fact that these two numbers are different. That is still a certain digit. It's because, because we flip over when we hit 10, right? We go from, do you guys understand what I mean? We flip over when we hit 10. Okay, good. So our uncertain digit is still in the hundredths position. Okay? And if you look at these ones, you can see, like if I go like this, those all look the same, yeah? They all look pretty much exactly the same. If I go like this, I say, are they exactly the same? That one, this one is just a tiny bit smaller. This one's just a tiny bit bigger. And this one over here is actually just a little bit bigger. But you can hardly see the difference. I only know there's a difference because when I made the shapes in Microsoft Word, they actually have different widths. Yeah? So they actually are different widths, but it's so small that you can barely see the difference. Okay? So, one thing to know about science, when we say an error in science, this is a big point, star that. An error in science is not a mistake. So if you are doing a lab and your teacher says to you, let's do some error analysis, what were the errors in this experiment? You don't say, oh, I dropped the beaker on the floor and lost some of my product. That's a mistake. That is not an error. Measuring this, the error, this digit is the error. It is the uncertainty. The uncertainty is the error. Okay? You are within a certain percent error, right? It's not wrong. It's just that there is a margin for error because your measuring tool is only so good. It's not a perfect measuring tool. That's the only way you could get zero error is if you had a perfect measuring tool, which we can't do. Okay? So, scientific errors are the difference between the observed values, what you measure, and what the true value is in nature. This is the actual value.
Is it possible to figure out the actual value?
You can get a very good accurate value. So let's say that like I've got a lab where you're going to find the density of aluminum, okay? Which I think we're actually going to do at some point, okay? We're going to find the density of aluminum. There are people who have done studies with aluminum and gotten a very, very, very precise density of aluminum. They got it to like 6 decimal places. We're not going to get to 6 decimal places with our rulers and our balances in the chemistry classroom, yes? Like that's just not going to happen. So we will have percent error. We will be able to compare our measurements and our values with the accepted value, the one that, people have spent lots of time working on. And we will be able to find the percent error. Okay, and that is if you take the observed or the measured value and I'll tell you what that line is for in a second, and you subtract the actual value, and then you divide by the actual value. So you're taking the difference between the measured and the real, okay, difference between measured and true, and then you divide by the true. And then you multiply by 100, to give you it as a percentage, that will tell you how far you are off the true value, what percentage you are off the true value. Okay, and so that's something we're going to use in labs. So the measured value is what we measure. The lines mean, yes, those lines mean absolute value, which means you take whether it's positive or negative and you just make it positive. And the reason to use absolute value, I mean, you could have it be a negative, like you could be like, I'm off by negative, it's too small by negative 6%, but it becomes a little confusing. So it's very often, I'm just off by 6%. Okay? So those absolute value, that just means make it positive. Okie dokie? All right. Like I said, if you want to include the uncertainty, and this will give us a good chance to introduce you to this little symbol here. That's a black diamond. Have we talked about the black diamond? I don't think so, no. Black diamond means that this is optional / bonus. Optional / bonus. So you can do this if you want to. And how those things work, I call it enriched. The black diamond is enriched. And how it works is that if you attempt it, like if you're writing a quiz and you try that question and you get a 0, it does not count against you. You can still get 100%. Okay? What I do is I take all the enriched marks and I put them in their own separate bin. And then I add 3% to your grade if you get 100% on all of it. If you got 50% on all of it, I would add 1.5% to your grade. Because 1.5 is half of 3. And if you're confused by that, you can just not worry about the math too much and just be like, it's a bonus. I can get credit for doing it and I won't lose any marks if I do badly on it. Okay, so that's how it works. I use this symbol because I like stars for things that are important. So I needed another symbol for an enriched thing. Okay. By the way, if you think doing the enriched stuff in chemistry, regular chemistry 11 gets you anywhere close to what we cover in chemistry 11 enriched, it does not. So if you're thinking, oh, I've done the enriched stuff in chemistry 11 and I would like to take AP chemistry next year, you won't be ready. The AP exam covers we go up to unit 8. Chemistry 11 enriched goes up to unit 13. Yes. So there's 5 units that we cover that you guys don't cover because it's like first year university chem. So don't take AP Chem unless you just want to challenge yourself a little bit and not write the exam, because then you'd still be fine taking the class. Like if you find Chemistry 11 a little bit easy, a little bit boring, and you're like, I would like to challenge myself a little bit, you can take Chem 12 enriched, but unless you're planning on doing a lot of self-study, like 5 units worth of self-study, then you would just take the course but not take the exam. Yes? Yes.
Okay, yeah, lots of friends will go into AP, but I thought in order to take AP Chem, you didn't take AP Chem or Risk 11.
You really should. You really, really should. I have occasionally had students who are getting 100% in Chem 11, right? 100%. I'm talking or 99, right? If you're in that position and you just want to have an environment where we move faster and it's more challenging, you would have to talk to me personally, right? Because I will teach it next year, and you would have to say, can I get your permission to do this? And I might say yes, and I might say no, and I might say these are the things that you would have to do to be prepared for it. Do you know what I mean? Which is neither here nor there. It's not something that most people do. Maybe 1 or 2 students per year, right, are sort of in that boat where they're like, wow, I really should have taken the enriched level in grade 11. I wish I had. And here I am bored out of my tree in chemistry 11, right? Because it's just so easy, right? Okay. So at any rate, that is an optional thing if you wish to write the uncertainties. Let's figure out which one of these would be correct. Would it be correct to write 0.80 plus or minus 0.1? Would it be correct to write 0.80 plus or minus 0.10? Or would it be correct to write 0.80 plus or minus 0.1? Which of those do we like? Have a little chat with your neighbor. Option A, option B, option C. Have a discussion.
This one we want to do, it could go to point one or 0.7, but this one I don't want. So that makes the same. So that this is what I was like actually.
Okay, ignoring the fact that option C is wrong because it has the unit in the wrong place. Option C is the correct option. Okay, I was going to have you vote, but then I gave you the answer, so now I'm whatever. Option C is the correct option, except that you would need to move the centimeters over here. Okay, it's all right. I got another one. There we go. Okay, so why is this one, at least the uncertainty part of this one is okay? Why is that so? There we go. Yes?
Because the last bit is the uncertainty.
Yes.
Right? So we're not estimating 0.8, we're estimating to the 100th place.
Uncertainty
would be C.
Yeah, so I mean, if we had A, it would be like, oh, it could be 0.80 or it could be 0.90.
Yeah.
Right, which makes no sense, or it could be 0.70. Ooh. You know, but this one would be 0.79 or 0.81. Okay, if you do choose to do this, the centimeter has to go after the uncertainty. You don't want to write centimeters plus or minus 0.01. What? You know what I mean? Like you need to have a unit here. It needs to be centimeters here, not centimeters before. If you wanted to write it both places, you could. Right? You could have 0.80 centimeters plus or minus 0.01 centimeters, but that seems wasteful and inefficient to me. But you absolutely have to have it at the end. Okay, now here's a question. This is the tricky bit. How many significant figures are in 0.80 centimeters? There are only 2. And the reason for that is if we take 0.80 and we write it in scientific notation. How many people are not familiar at all with scientific notation? Have never heard of scientific notation? It's okay if you haven't, we will be learning it. Okay, but just for now, I can take this number and I could say this is the same as taking the number 8 and multiplying it by 0.1. Yes? Is that correct? 8 times 0.1 gives me 0.8. All right? Now, 0.1 is 1/10. Yes? So this is equal to 8 times 1/10. Okay? And the number 10, I could write it as 10 to the 1 because 10 to the 1 is just 10. Yes? And I don't know how good you are with your exponents, but 1 over a to the x is equal to a to the negative x. Okay? If you don't know that and you're not following, it's okay. Don't worry about it. We'll hit it a little bit later. All right? So this is equal to 8 times 10 to the negative 1. That is our scientific notation. Now, if I were to write it in scientific notation, really, because I have 2 sig figs here, I should be writing it as 8.0 times 10 to the negative 1, and that would have 2 sig figs. Do you see how this 0 here just went away? Right? Where did that 0 go? It was just a placeholder. It was a placeholder telling you my number has not started yet. I don't have anything in the ones position. I could actually write zeros like this. I could be like, oh, look, I don't have any hundreds. I don't have any thousands. I don't have any 10,000s. Oh, look at me, right? Those are just numbers. Zeros at the beginning tell you that your number hasn't started yet. Your number only starts when you hit a non-zero digit. Okay? So, non-zero zeros at the beginning of a number, we call them leading zeros. They are never significant. Okay? Leading zeros. You don't need to know the word leading zeros. I'm not going to ask you what is a leading zero, but zeros, they are zeros that are to the left of non-zero digits. Those would be these ones here. And they tell you that your number hasn't started yet. They are not sig figs. And if we take 3.00340 and we turn it into scientific notation, yes, yeah, take the flash. If we take those 3 zeros out of it, we have 1, 2, 3 sig figs, 3 SF. Okay, so if we write it in scientific notation, we write 1, 2, 3 sig figs. And if anyone wants a little preview of how we do exponential notation, scientific notation, what we do is we move the decimal until we have a single non-zero digit in front of the decimal. Yeah, for sure. And now I have 1, 2, 3, 4 sig figs. Okay, 4 sig figs. So I need to write 2.600, and this is going to be times 10 to the, I've moved my decimal place 2 places, so it's going to be times 10 to the 2. If you didn't catch that, don't worry, we have a whole section on doing exponential notation. So if you're like, what? It's okay, that was just a preview. Okay? 4 sig figs. So leading zeros are not significant. And I'm going to give you this little mnemonic right now, because we're going to use it over and over. NIM. No, yes, maybe. No, yes, maybe. And right now we've just done the no. Those are zeros on the left, and they are not significant. No. What do you think about zeros in the middle? What do you think zeros in the middle are going to be based on this little thing? Yes?
Zeros in the middle to a non-zero digit are significant. The zeros in the middle of 2 zeros are not significant.
All zeros in the middle are significant.
All zeros?
All zeros. Your physics teacher lied to you. Or maybe they just said it differently.
No, that's what he said. He was like, zeros, if the zero is in between a zero.
But no, there have to be non-zero digits on either end. Yeah. But you can have a 0, 0, and a 0, and that's okay. Those are all significant. Okay? So the Y stands for yes. Zeros in the middle are always significant. Yes, they are. Zeros in the middle are yes, significant. And if N stands for no and Y stands for yes, what do you think M stands for? No, yes, what's our other choice? Maybe. Okay, and we'll learn about what context, when are those zeros on the right significant and when are they not? Okay. Okay, so here we go. Let's look at this beaker here. What is the volume of water in this beaker? I would like you to chat with your partner about that.
I think it's a 6.1. Oh, wait, can I show you something with Spence? This is what sick thing.
Chemists know more about safety than physicists because, quite frankly, you care more about precision when you're, like, say, making up somebody's pills for, like, you know, their medicine than you do about, you know, the speed of a bowling ball. And usually the numbers in physics are quite large, so sig figs don't make as much of a difference anyway. So they just are kind of like,
Yeah.
it's okay.
Numbers, 1 and 8 here.
Yeah. Always significant, yes.
Even between 2 zeros.
Well, it doesn't say that there though. If he said it, then he's wrong. And you can tell him that your chemistry teacher said he's wrong and he can come talk to me about it.
Okay.
All right. What is the volume of the water in beaker A? Around 60. Now, is it like 60 or could it be 61? Yeah. Is there any way that that is 70?
No.
No, right? So our uncertain digit, it could also be, you know, it doesn't look like it could be 59 to me. It's probably just either one of those, yes? So our uncertain digit is this one here. All right, now we're going to look at the beaker on the right. Have you done the volume for the beaker on the right? Thank you. What do you think about that beaker on the right? Probably about 60? Could it be 50? Maybe. Could it be 70? Maybe. You know what I mean? Like you're not sure because there's only a 0 and a 100. Yes? So if we have only 0 and 100, then we can only guess at the tens position. So this is our uncertain digit. So how am I going to tell you the difference between 60 milliliters here and 60 milliliters here? Because they are different, right? This one is like, this is my uncertain digit. Over here, this is my uncertain digit. There has to be a way to say that 0 is significant and the other 0 is not significant. Couple ways of doing it. The easiest way is to put, didn't like that, a decimal. Stop doing, There. Put a decimal after it. If there is a decimal in the number, that's where the maybe comes in. Maybe. If there is a decimal in the number, zeros on the right are significant. So how many significant figures in 60 point? 2 sig figs.
But if there was no decimal, the only 6 fig that there would be there is the one. The 6.
Yeah, the 6.
Yes.
Yes. So if there is no decimal, zeros on the right, R for right, are not significant. So I like to say decimal, no, not significant. Decimal, yes, yes, significant. Decimal, no, not significant. Decimal, yes, yes, significant. Decimal, no, not significant. Decimal, yes. Thank you. I got a couple people. Everybody on my, your right-hand side of the room. Decimal, yes.
Yes, significant.
That was sad. We're going to do it again until you say it out loud for me. Decimal, yes.
Yes.
You guys can do better, right? Because that was sad. You guys can do so much better. Decimal, no.
No.
Yes.
Decimal, no.
No.
Okay, let's try that one more time. Decimal, no.
No.
Okay, over here. Decimal, yes.
Yes, significant.
Decimal, no.
No.
Decimal, yes.
Yes.
God, you guys are terrible. My last block of the day, they kicked your ass singing the song the other day. Got to tell you, we can have a little competition here. We'll see how they do with this yes and no. Okay. So those are for zeros on the right. So no, yes, maybe. And for this maybe, yes, decimal.
Here.
Yes, significant. No decimal. No significant. Is good? Okay. So no, yes, maybe. All right, blah, 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 blah. Oh, here's a couple other things. All right, so we have a couple weird little doodads here. You can write a decimal in the number. That's one way of dealing with it. So this has 1 sig fig, whereas this has 2 sig figs. You can write the number in scientific notation. 60 is equal to 6 times 10, which is the same as 6 times 10 to the 1, because 10 to the 1 is just 1. So scientific notation, you have to have a number up here, okay? So it's 6 times 10 to the 1, and you can see that 0 at the end went away. So we have only 1 sig fig. This would be 60, okay? This, here, we have, you choose the washroom, take the flash. 6.0 becomes, 60 becomes 6.0 times 10 to the 1, and we have 2 sig figs. All right? Now, there is this other thing. You will not see this anywhere other than in this course, okay? It is an overbar, and you can use it. It doesn't mean repeating in this case, okay? Not repeating. The overbar here tells you that it is your last significant figure, okay? And what it's going to let you do is it's going to let you say, if I have the number 600 and I want this one to be my uncertain digit, it's telling me that that is my last significant figure. It tells me that is my uncertain digit. Just give me a second. I'm just going to write first, okay? The tens is the last significant, excuse me? digit. It is the uncertain digit. So how this would normally be written, we often would not write it like that. We would usually write it as 6.0 times 10 to the 2 sig figs. If you don't love the overbar, you can just be like, I don't like the overbar. I'm going to write it in scientific notation. That makes more sense to me. Okay?
But I thought the last estimated digit has to be the.
This is our uncertain digit here. Uncertain digit here.
But then, okay, I get it.
Yeah? Don't get too wound up about the overbar. If you hate it, you don't have to use it. Okay? Basically, the number after the 6 in this particular example would be the uncertain digit. I'm not referring to any specific measurement here.
Okay.
Okay? I'm just making up a number out of the air. Okay? Yeah.
And for example, if you go back up, like for the second part of the question where it doesn't show the beaker, or it doesn't show the mark.
Yeah.
The 6 would have the overbar, that overbar over it, right?
We don't put overbars over the 6 because zeros on the right are not significant. We don't need to put an overbar over the 6 to know that the 6 is our last significant digit.
Okay.
It only has to go over a 0 when we're like, which 0 is my last sig fig? So if I had, 60,000 and I was like, oh, but my measurement was good to the hundreds, I would write it like that, which would be 6.00 times 10 to the 5.
Oh, because my measurement is only good to the hundreds.
My measurement is only good to the hundreds, yes.
The number is actually 60,000.
Yeah.
Okay.
Yeah.
So in this case, the number is only good to the tens because of 600, but my
Yes.
my number is 600.
Yes,
Okay.
exactly. Okay? All right, so trailing zeros, those are zeros at the end. Those are zeros on the right. Trailing zeros, zeros on the right, are significant if and only if there is a decimal in the number. That's the maybe. Yes? Those are our maybes. Let's see. How many sig figs? This is example 7 on page 72. How many sig figs in 100.0? 4. Because we have yes decimal, yes significant. How about this guy here? How many sig figs? 3. Yes, des? Yes, sig. How about this last number here? 1 sig fig. How could you write this number with 2 sig figs? You could use an overbar on the second digit. Okay? Non-zero digits are always significant. I think we got that right. Like, so if you have a 9, it's a sig fig. Captured zeros, those are the ones in between. We're not gonna, blah, 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 blah. Okay, this is on page 75. On page 75, we have no, yes, maybe. This is our just one little example that in case encompasses them all. No. Yes. Maybe. Decimal. Yes, we have a decimal. Significant. Yes. And therefore, how many sig figs are in this number? I'm going to give you some choices. We have 8, 11, 10, 8, 6, 4. Chat with your partner. Which one do you like? Okay, remember these ones are not significant, so we do not count them. Zeros on the left never count. It doesn't matter if they're after the decimal. If they're on the left of non-zero digits, they are not significant. They can be before the decimal, after the decimal. Doesn't matter if there's nothing to the, if there's no other non-zero digits there, they are not significant. I could even put extra zeros in here. I could have 0, 0, 0, 0, 0, as long as I have a non-zero digit on either end.
Yeah.
All of these are significant. All of them.
Yeah, that's what I meant.
Yes.
But if there were 2 zeros at the other end, it would not be significant.
No.
That's what I meant.
Okay, fair. Yes, that's correct. That's correct.
That's correct.
Okay, so this would be 1, 2, 3, 4, 5, 6, 7, 8. And these ones are maybe, but the answer is there a decimal? Yes. Are they significant? Yes. So we have how many? 8. Okay. I don't know. We're kind of running out of time here. So let's just, for homework, you guys can do pages 77 and 78. And why don't you try the examples on page 76? 76, 77, 78. Okie dokie? Yes. Yeah. Yeah. Then they average. Yes. Yes. Yeah. Oh, hi. I'm back with the phone. Okay. Yeah. You wrote everything. We were in the same. No, that's not. No, I studied. Yes, I love it. I'm in the Discord server. And I needed how to do that.
But it doesn't like it. Like it's not like I fall. It's just like maybe like
You go here?
it's just like an extra practice that you perhaps it's
Gonna go big.
She might be going.
Oh man, I want to print this one.
Oh.
Yeah. Yeah, I think it's kind of like
You should have taken that one, Chris. I don't know why you dropped out. Where, what are you going to do? Double why? You didn't talk. I know, I know.
Folks, on page 76, filling in the blanks is kind of hard, but just try and come up with the number of sig figs in each number, okay? If you can fill in blanks, that's wonderful, but if you don't have to, okay? That is correct, yes. Or you could just write 61. Okay, yeah.
Yeah, but I don't work well.
Anyone else have any questions?
Yeah. You actually? I did. He never emailed me. I think he had your answer. I don't talk to him.
Yeah.
I checked.
It's a long, long-
I think because I wasn't one day. He got mad. It's all right. Yeah, so they're like, okay.
I already know.
Or.
Yeah, yeah, so it's kind of like, in the beginning, it's like, you know, maybe those first two,
My mother wanted me to become a psychologist. Like I said, I cannot sit there and do one thing that's wrong. Yeah, what's the analysis?
The homework is 76, 77, 78. Yeah.
You know, he's simple. You know, does he go here or is he our judge?
Next time, feel free, right? There's just lines like that are sort of
Bro, I'm so used to it. I used to live in Maybe sad. No. Fine, let's walk in through the phone. No, I'm. Okay, so let's study over the summer.
Well, gonna go?
So stack is 41.
41?
Yeah.
Look, I see centimilli, micro, nano. Oh no, that's the other one. Liters, meters, moles and Kelvin, kilograms and seconds. You have a quiz on this on Monday.
On Monday.
Liters, meters, Monday. Meters, moles and Kelvin, kilograms and seconds. Yeah. It's how many little quizzes up, right? Yeah.
Absolutely
Yes. No idea. It says maybe it is, but I don't know for sure. It's definitely not mine. It's, yeah. Yeah, for sure. Captured zero, but you don't. Like I said, it's called zero. The actual names are not important. Understanding whether they're saying food or not is what's important.
Okay.
Yeah. Oh my gosh, I can't wait for the weather to be a little less dry.
Water's been snowing the weekends.
Yeah, I'm so thirsty. Like I haven't been this ever. It's just so dry.
On! Che poi l'uovo vedi? Sì. Confermo. Per 40.000, per 10.000, guarda. L'uovo vedi? Via. L'uovo vedi? Biliş. Ay biliş böyle. L'uovo vedi. Yok, bu ben borç var.
Hello. It's Chelsea, right? Yeah. Did I teach you before? No. But you look a little familiar, but maybe that's just because you smile a lot. I don't know. Hi. Oh. Mahan.
Yeah.
Mahan.
Yeah.
Oh my gosh.
I know that's
Now you guys are gonna confuse me.
Yeah. Oh, there is another Mahan too. I have class with them.
Yeah.
Two of my classes. So when the teacher is calling them out, like the
Yeah.
doing the whole thing,
Yeah.
I'm like it says Mahan, and we both raise our hand up. So I said, which one are you talking about? Mahan M or Mahan S? So
There was one class I had 4 Sophias, but they were all spelled differently.
like I think half of it is still called Mahan.
Mahan. These days, yes.
Sure.
Yeah, why not? What the heck?
Okay.
Okay. I've got Celia, Mohammed, Simi, very last. That's one. Xavier. That's
Actually, also. Right, it's this guy's the main character, bro. You're the main character. Second main. Like I asked two, calls the main. Yes. Fine. Yeah, like, what do you want me to do? Yeah, sorry. See, look, this is good though. It was awesome. It's gone.
Okay.
I'll be right back and grab some water.
How was your hand?
Yeah.
Basketball.
Yeah, she's gonna stand. Oh my, you're moved up. No, let's think. Oh, it's bad. It's the same.
It is roasted, so simple, but that's hard. Yeah, because it's not, it's literally solidified. Alrighty.
Is there anyone here who has not been here for the last couple days? Anyone new? Yes, but you got your book already, so I don't need to give you a book. Perfect. Okay. And I have been studying your names, so I'm going to try today to do it real quick. While I do that, oops, I'm going to press stop record.